Hello, we're going to go ahead and begin the webinar. My name is Greg Jutras, and I'm with a company called HVAC Solutions. What that means is I work for Temperature Equipment Corporation and the National Excelsior Corporation, and we are a HVAC distributor based in the Midwest. Today we're going to talk a little bit about Honeywell generators. And if you have any questions during the webinar, please feel free to type them in. I believe it's on the right-hand side of your screen, and I will do my best to get them answered throughout this presentation. If for some reason I miss it or I get caught up, I will get you an answer to your question today. So, if I start at what I'll call the beginning, years ago we used to sell Carrier and Bryant branded generators. And a few years ago, I'll say about 3 years ago, the relationship between Generac and Carrier ended. And so Generac was looking for a brand name to go after the HVAC market. And out of all the different brands they could have, they chose to go with Honeywell. And I'd say there's one basic reason for that. If you look at the bottom of the screen, 92% of customers have heard the name Honeywell. I would say that it's hard to go to a homeowner that hasn't heard the name Honeywell before. In the HVAC industry, we think of Honeywell as, thermostats, zone control. But to the average homeowner, it means a lot more than that. There's a lot of portable units that they could use. There's a ton of presence out there with security systems. So the point is, Honeywell has the potential to be not in just one room of somebody's home, but in almost every room of a home. I'm not going to spend a lot of time on who buys generators, but you can see that the lion's share is those people in the age range from 45 years of age to 65 years of age. So my point is, it's not the young 20-something who's buying their first house. Most of the people are a little more seasoned who are buying generators. When we talk about income levels and who buys generators, this slide surprised me a little bit because I thought there was going to be a lot more people on the right hand of that scale. But the reality is the majority of people who are buying generators make somewhere from $35,000 to $100,000 a year. It's not the people making, $250,000 a year. Now, the reality is there's an awful lot more people making $35,000 to $100,000 a year. So the numbers are skewed a little bit, but nonetheless, the majority of generators are being sold to that market. Here's a quick heat map of the United States. And basically the red means there's a lot of power outages. You can see there's a lot of red on there. We're based in Chicago, so here is a map of Illinois, but you can see that there are a ton of outages in the greater Chicagoland area. It affects millions of people. We talk about who installs generators. Not surprisingly, the majority of people who install generators are electricians. But what you can see there is that the HVAC, while the numbers are much smaller, HVAC is growing at a much larger clip than the electricians. So who needs generators? It's pretty much everybody. We could put it that way. But what I'd like to point out is that people buy them for different reasons. Business owners buy generators to make sure that that cash register keeps ringing. If you take it on a larger scale, manufacturing processes, people can lose millions of dollars if the power is out for any length of time. 1 week can literally be millions of dollars to a factory. Homeowners, obviously not concerned about the cash register as much, but they don't want the basement to flood. They don't want the food in the refrigerators to go bad. So both markets need and want generators, but they want them for different reasons. We talk a little bit about the product mix in the Honeywell offering. The little guy there in the middle is what we call an inverter. Now, I start with this one first because the terminology gets a little, I'll say, crazy. People want an inverter because they think it means clean power. And by clean power, I mean, it's clean enough to run a computer. It's clean enough to run a HD flat screen TV, right? So people say, I want an inverter when there are no standby units that are inverters. What I will say is that the power coming off of a standby unit is much cleaner today than it was even 5 years ago. So we have no problem running computers or flat screen TVs. So that little inverter in the middle, it's really small. We're talking watts. So that's great for tailgating. It's going to run a blender, but you really don't want that thing to run a refrigerator. The one on the top right, that is what we call a portable. I like to call it a two-wheel dolly. We see these a lot in new construction when you need to bring power to a job site. It's great for running a handful of home appliances when the weather gets bad, a refrigerator, a sump pump, those kind of things. But really what we're going to focus on are the home standbys. So your, I'll say, residential and commercial generators for backup power. They're going to come on automatically. The Honeywell lineup for air-cooled is pretty simple. It's basically 10, 15, and 20 kWs. So we've got 3 sizes. That's actually going to change a little bit. So in the near future, and by near I mean in a couple weeks, we're going to see an 11 kW, a 15 kW, and a 20 kW. But that varies from some of the competition. We don't have a 7 kW, an 8 kW. We're 10, 15, and 20. We don't have 12, 14, 16, 18. So what we find is that it's a lot easier in terms of sizing, and that we can generally put a homeowner into the right size machine and cover their issues. As we get into liquid cooled, the Honeywell product line goes up into the 150 kW range, but we stock in single phase 25 kW, 35 kW, and 45 kW in single phase. If you needed a 3-phase machine, it's a 6 to 8 week lead time because those are much more custom. Right, so I started talking a little bit about Generac partnering with Honeywell. So this is a Generac-made machine. The benefit of that is that Generac has almost 74% market share. So they're a dominant force in the generator market. What that means for us is that we have a reliable engine. We have an engine that, 3 out of 4 machines out there is made by Generac. What makes it different are these 6 features. So this is where the Honeywell part of it comes into play. So it's a Generac-made machine, but Honeywell has what I'll call their spin on it. It's really packaged a little bit different. It's packaged to be a higher end or a premium whole house generator. So these 6 features are what we're going to hang our hat on, that we can say comfortably across the kitchen table, this install is going to cost more than the guy down the street. And here's 6 reasons why. So the whole idea is to get other people to play our game instead of us trying to play the pricing game. So this is the sync controller. This is the circuit board in the outdoor unit. This is what I'm going to call makes most of the magic we're going to talk about happen. So this thing talks with the transfer switch and allows for load shedding, which we'll talk about more. And it also will send information to the remote, I call it remote control in the house. I bring this up because a lot of times I get asked, can I take an old generator, put in a new circuit board, and make it a whole house load shedding generator? Well, the short answer is yes, you can do it. The long answer is I don't recommend it because there's no manual showing you how to take an old generator and making it into a new one, and those wires never seem to line up right. So it gets to be, I don't say a nightmare, but pretty close to a nightmare. Here are a few of the transfer switches that are available. We stock service-rated transfer switches in the 100, 200, and 400 amp sizes. All of these type of transfer switches are NEMA 3 rated, so they can be mounted outside. We also stock 100 and 200 amp non-service rated transfer switches, which can also be mounted outside. The difference between a service-rated transfer switch and a non-service-rated switch is that a service-rated switch is going to have a circuit breaker inside of it. A non-service-rated switch does not. So all that really means is that it changes the positioning of the transfer switch in your system. A service-rated switch will go before the customer circuit breaker box, while a non-service rated switch will go after the customer circuit breaker box. So in theory, they're exactly the same except for that circuit breaker that's in it. And service rated means it has a circuit breaker and will be therefore mounted before the customer circuit breaker box. Non-service rated does not have a circuit breaker and will be mounted after the customer circuit breaker box. All right, so here is what I call the old way of doing generators. And this is the way that I'm going to say most people are familiar with. So all the way at the left, we'll say we go from the meter to the customer circuit breaker box. Then when power is off, we power up the box that's the transfer switch that's on the right side of the circuit breaker box. And generally speaking, you'll get about 16 circuits that will have power when the power is off. So those 16 circuits are what the generator is feeding power to. Now again, I call this the old way of doing it because we are doing it a new way. I'll explain that. So what we're trying to do is give the homeowner the entire house. So what we do, we go from the meter to the transfer switch, and then we back up the entire circuit breaker panel. So if I was standing in front of you, I would ask, what is difficult about this installation? And I would then proceed to tell you that the problem with this one is, where do you cut the power? Well, the power in this case means you have to pull the meter. And for the sake of argument, a good portion of HVAC contractors are not comfortable doing that. So that's where a subcontractor would come into play if you don't have an electrician on staff or somebody who's capable of doing that. So that's the first problem with doing it this new way. If I go back, what is easy about doing it the old way? Well, the first thing is that you've got pre-wired whips. You've got a whip that goes out to the generator, and you've got a whip that goes to the circuit breaker panel. And secondly, where do you turn off power here? Well, it's pretty simple. You flip a switch in the customer circuit breaker box. It cuts off power, and then you can do your work. So then I would say, what is difficult about doing it the old way? Well, the first thing that's difficult is that you have to choose what 16 circuits you want to power. And that, might take an hour. It might take a little bit longer than that to figure out what 16 circuits Mrs. Smith wants to have on when the power is off. The other small problem with this is that if you have 16 circuits, that's a minimum of 32 wires that you have to connect. So it's an awful lot of wiring. Plus, they give you a 30-foot whip. So if you're only 5 feet away from the circuit breaker panel, you have to cut that down and kind of redo it anyway. So with this, we're really only bringing 3 wires from the meter through the transfer switch and to the customer circuit breaker panel. Now, these wires are a lot bigger than the circuit breaker wires. They absolutely are. So you're dealing with a lot bigger wires, but you're dealing with a lot less wires. So how does all this work? Well, if I was to run through what is going on here, this circuit board is inside of the transfer switch. And if I run through a sequence of events, we lose power, the generator kicks on. We send power through the transfer switch, and the first thing that happens is that we give power to the circuit breaker panel. And when I say circuit breaker panel, what I'm really talking about is the 115s. So the 115 volt circuits on that panel. So in a house, what are the 115 volt circuits? Well, it's the outlets, it's the lights, it's the refrigerator, it's the TV, it's the sump pump, even the garage door. So the first thing that happens is they get all the necessities, right? They got lights on, their fridge is on, their sump pump's on. They can even play Xbox if they want. They got all the 115s. Then power shoots over to this circuit board that's inside of the transfer switch, and it starts looking at AC1 and L1. And it says, do I have enough power to run these items? Now, the beautiful thing is that you can set the priority. You can play with this a lot of ways. But let's say we've got a bigger generator, not every light in the house is on, so we turn on that air conditioner and we turn on, in this case, an electric hot water heater. But let's go down a little further. AC2 and L2. Let's say that there is no air conditioner, but L2 is an electric range, and we're able to turn that on. So we go down to L3, and let's say that L3 is an electric dryer, and the generator's working as hard as it can. It just cannot turn on that 240 volt electric dryer while everything else is on. So what it's going to do is shed everything that's on this circuit board. And it's going to wait a few minutes, and then it's going to slowly bring them back on. So AC1, L1, L2, L3. Maybe it knows that L3 was the problem, so it's going to skip down to L4. And let's just say we don't have an L4. So everything's running except for L3. Half hour later, it'll come back and double check that L3 and see if it's enough things have changed on the panel to make it possible to run L3. So then I'll have people that say, I've got a house that has a well pump. And a well pump is not like a sump pump, it's a 240 volt load. They say, well, you know, when power's out, I really want to run that well pump. So, well, you got two options. First option is, let's not shed the well pump at all. We'll leave it on the 115 volt side of the circuit breaker panel. The penalty for that is you have to make sure that that generator is big enough to run everything that we're not shedding. Say, well, we're pretty close, so I'm going to shed it, but I want it to have high priority. So now what we do, we take that well pump, we put it in L1. But we take the air conditioner, and instead of putting it at AC1, we're going to put it down to AC2. So that the first thing that comes on is the well pump. Second thing would then be the air conditioner. Then we can look at, you know, dryers and ranges and other things like that. So this is an important slide, so I'm going to run through this one more time. We lose power, the generator kicks on. First thing that happens is we send power through the transfer switch to the 115s in the house. They get all their necessities. Then power shoots over to this circuit board. We start looking at what we can run. And we do that based on frequency. So we're trying to keep a minimum of 60 hertz. And when we drop below, I believe the number is 55 hertz, we start shedding. So the minute that we're not able to produce clean power, it's going to shed because that generator is doing all it can do. So AC1 and L1 would come on, AC2 and L2, and then L3 and L4. So that's kind of the sequence of events. On the left side of this circuit board, AC1 and AC2 are 24-volt circuits. So all we're looking to do here is cut the Y wire from the thermostat. So we're looking for control wires there. On the L1, L2, L3, and L4, I want to talk about two different things because we are right smack dab in the middle of model number changes. So older transfer switches, this side is going to be a 110-volt circuit. So in that case, you need a DLM module. And that's that little box right in between the circuit board and the customer circuit breaker box. And really what that is a 50 amp contactor. It's allowing us to either open or close that circuit based on what the L1 through L4 is telling it to do. So for every 240 volt load that you shed, you need a DLM module, save the air conditioners, because those are 24 volt. Now, if I jump ahead to the new switches, which we do have some in stock, both sides are 24 volts. So AC1 and AC2 work the same as they did. L1 through L4 are now 24 volt connections. You still need a contactor, but you also need a transformer, and that's sold in a kit. The benefit to that is that a lot of codes will allow 24 volt wires to be run either in the I'll say surrounding areas of that transfer switch. So you're able to do a lot more work without having conduit. So older switch, it's a 110 and you need a DLM module. The new switch, both sides are 24 volt and you still need a contactor, but it's in a kit that also comes with a transformer to allow you to do 24 volt work. Here's a picture of the DLM module, and it's basically just a 50 amp contactor in a NEMA 3 box so that this guy can also be mounted outside if that's where you're putting the transfer switch. Here is the really quick down and dirty sizing guide. I use this one with technicians who may not necessarily be doing sizing or selling, but they can at least tell a homeowner, you know, you have this size equipment, here's probably the size you're looking at. So at the top, you can see where it says 10 kW. If you take that down, a 10 kW will run a 3-ton air conditioner. It'll start and operate a 3-ton air conditioner. 15 kW will start a 4-ton, and a 20 kW will start a 5-ton. What I want you to notice is that on the side where it says 5-ton air conditioner, there's a little 2 after it. That is because we can physically hook up 2 air conditioners to that circuit breaker, or I'm sorry, to the circuit board inside of the transfer switch. The problem is a 20 kW is never going to start 2 5-ton air conditioners. What it will do is start one at a time. So in a 2-story house, you know, maybe one unit is doing the first floor. You want that one on, the thermostat in the on position during the day, and then turn it off when it's time to go to bed, and then you turn the upstairs one on. So you can hook up 2, but don't think that the generator is going to start 2 5-ton air conditioners. So this is Generac's sizing guide. I bring this up only because every once in a while I run into a homeowner who says, Generac said I can use a 8 kW. I said, well, you got a 4-ton air conditioner, so you really need a 15 kW. We're looking at almost double what you thought. So just be aware that this is readily available. People will use it to get an idea of what they're at, and you might come in and tell them something completely different. If you run into critical applications or hospitals, give me a call. We have lots of software available to help size that kind of stuff. Maintenance kits. Maintenance is required on these units. My recommendation is twice a year and also after an outage. So twice a year regardless, and then also after an outage. I recommend that because these units use oil, and you have to check the oil because it goes away after an extended period of time. And we do offer maintenance kits not just for, or I should say not only for Honeywell, but for all the lines that Generac makes. Cold weather kits. Here in Chicago, I do not recommend them unless the application calls for it, and by that I mean the application is critical in some fashion. You know, somebody on life support, yeah, let's put in the cold weather kit. Or maybe somebody needs the stair lift to get from one floor to another. You know, that's a critical application. You know, those kind of things. And I don't generally offer them because it's an expensive kit. It's basically a crankcase heater. But this thing costs in the neighborhood of $250, and generators are pretty tight. So if you're offering it and the other guy isn't, you'll look that much further out of the ballpark. The other problem with them is that you have to run 115 volts out to the unit. Most people think that once they're done installing this thing, they can just, you know, throw it in there and plug it in. And the truth is you have to run 115 volts from the house out to the generator. It is not producing its own 115 volts. So I can't tell you how many times contractors have gotten caught trying to leave a job and they don't have power to that unit. And it makes for a pretty frustrating night. This is Honeywell's website. What I want you to notice there is their service and support tab. So it's kind of on the top, first tab you'd go into. This is where, via model number, you can get specifications, literature, those kind of things, if you're looking for something at midnight and you can't find it. The other thing I want you to notice is that the last tab there is the dealer locator. So that's where we want homeowners to go to find somebody to install or sell them a Honeywell generator. In Honeywell's world, there's two different types of dealers. There's a sales dealer, and then there's also a sales and service dealer. So two different levels. The sales dealer basically means the dealer is able to buy a generator and install a generator. They will also put them on the website as a sales dealer. To become a sales dealer, all you really have to do is buy a generator, fill out the paperwork, and then watch a few online videos. So it's pretty simple to become that. What I would recommend, though, is the sales and service dealer. This means you're able to do warranty work not only on just Honeywell units, but any generator that Generac makes. And they make the old Carrier, Bryant, Honeywell, Generac, of course, but there's also Eaton, Siemens, Watchdog, and there's probably about 3 more I can't remember. So it allows you to do warranty work on all those units out there. The price of admission for becoming a service dealer is that you have to pass the 2-day air-cooled certification training. We do hold those here locally in Melrose Park. I do about 4, maybe 5 of those a year, but they're also held in Wisconsin if you're closer to Wisconsin. After somebody passes, and by I mean pass, there's actually a test at the end of the class that the person has to pass. Once the training is complete and passed, there's a parts kit. Today, this parts kit is, I'm going to call it $400. It's $3,500 worth of parts, but over the years we've dropped the price of that parts kit just to get more dealers able to do service. So after you buy the parts kit, after you pass the test for the 2-day class, you have to fill out a form, and then you are a service dealer for Honeywell generators. One thing I like to always bring up when we're talking about generators is selling the quality of the install. The number one issue that Generac gets is that the gas line is too small. And I can tell you horror stories of, gas lines tapped off after the furnace and a 1/2-inch gas line run to 20 kW. They don't understand why it won't start. So gas line is too small. And then the other thing is, a lot of times gas meters have to be upgraded. Sometimes they're not big enough to handle a generator and all the other gas appliances. I would say on a 10 kW, you've got about a 50-50 shot. 15 or 20, I would definitely do some math and see if that gas meter needs to be replaced. Here locally, there is a charge for doing that. It's anywhere from $300 to $400, depending on who you ask and who's coming out to do the service. The bigger problem is that it takes a long time for them to get out there, anywhere from a month to maybe 6 weeks. So just be prepared for that. So the install, these units do require batteries. It's a 26R, it's a 12-volt deep cycle battery. Currently, we do not offer these, but I do plan on offering these in the near future. So just know, when you buy a generator, you're still going to have to buy a battery. And you can pick these up at any Walmart or AutoZone. It's a pretty standard battery. Control wires. When I talk about control wires, I use control generically as the wires from the circuit board in the outdoor, let's see, in the generator outside, the circuit board outside, to the transfer switch, which is either outside or inside. But to me, control wires in this sense, it's going to be something in the neighborhood of 10 gauge, could be 14 gauge, depending on how far you're going, but it most certainly does not mean thermostat wire. So please do not use thermostat wire if I tell you to use control wires. Service and maintenance. I would not discount the ability of going and servicing the generator, doing maintenance on that generator. That is where the bulk of what I'm going to say, profit, the biggest profit opportunity on this thing. Generators, yeah, you can make a few bucks doing the install, and that's great, but a lot of guys walk away after that. They're not qualified. They don't have the mechanical aptitude to go back and service and maintain the generator. And this maintenance is not what I would call a $79, $99 clean and check. It's more involved than that, and therefore should dictate a higher price tag. So just don't discount that, because not everybody can go back and service it. Transfer switch being the wrong size. Now, we size transfer switches based on the amount of amps coming to the house. So if you have 200 amp service coming to the house, we are going to recommend a 200 amp transfer switch. If you're talking service rated, which is probably about 90% of what we do, if not a little bit more. What would happen if you have 200 amps coming to a house running through a 100 amp service rated transfer switch? Well, I can tell you, A, it's going to get overloaded an awful lot, but best case scenario, you just cut down the delivered amps to that house to 100 amps. So power from the house actually runs through the transfer switch. I just want you to understand that, because a lot of times, hey, I'm just using a 10 kW, and you know, why would I need a 200 amp switch? Well, because power from the house is running through it. Standbys versus portables. We actually love people who have portables, because about half of the people who buy a portable unit will eventually buy a standby unit. Why? Because they get tired of running cords. They get tired of, you know, trying to put gas in this thing when it's raining out. Or they put it in the garage and they don't want to, you know, worry about carbon monoxide. So a lot of people that buy portable units will eventually buy a whole house unit. We've had great success with HVAC guys who cross over into plumbing, and guys who are successful selling backup sump pumps. You know, they're going to spend, you know, $1,000 or maybe even $1,500 to back up just the sump pump. Why not put that towards a whole house generator and get everything else? So we've seen a lot of success with that. When we talk about the noise, and I'll tell you, these things sound like a riding lawnmower. They are not quiet. The nice thing is that when they exercise, which is once a week for about 12 minutes, they run at about half capacity. So it's not full blown. It's running at a lower RPM, and you can have it come on when you would like to. So it doesn't have to be, you know, Sunday at 2 in the morning. You can have it Saturday morning at 10, something like that. So I talked about the 6 different features that make this unit different from what the other guys are offering. What are the decibels at 40%? I'm going to say there's no actual testing on that, but I'm going to say you get about a 20% reduction in the sound. And then they're also going to tell you that because our units are aluminum, the steel doesn't rattle, or the aluminum doesn't rattle like steel does, and so the decibels are a little bit lower. So I'm going to say safely, and I can't put this in writing because it doesn't exist, but you're going to be in that 40 decibel range. So first thing I'm going to talk about is the remote monitoring. In the remote monitoring, I want to start by saying that this is on the older units. So we're in the middle of a model change. I still have some of the older units, and I do have some of the newer units, but this remote is on the older units. Now, nice thing about this is that it comes in the box, and it goes in the house. Well, as you can see there, it's not the prettiest thing. So I try to, put it in the garage or, somewhere in the kitchen, out of the way, but to where you can still at least see it. The nice thing about this is that it tells them everything that's going on with the generator. It exercised, life is good. But if there is a problem, like we're running on low battery or whatever it is, they're going to know to call the contractor and get them out before it's an emergency. If you don't have it, when do you know there's a problem? Yeah, the once or twice a year that you need it, because there's an outage. So the reality is you're using this thing once or twice a year and it's not working. So it makes people pretty upset. The second thing we have, and these are standard, is base fascia. So the base fascia is kind of that little skirt at the bottom of the unit, finishes it off, covers up the forklift holes, makes it look nice. But the best thing about it is that it keeps rodents out. Generators are nice and warm, keep rodents out of the rain. So the base fascia, even though this is only like a little $50 upgrade on the other side of the fence, we include it in the box, and it keeps rodents out. Like I just said, we have an aluminum cabinet, whereas the other guys are going to be steel or maybe even a polymer type of plastic. What this allows us to do is not rust. These units are designed to last a long time, and generally speaking, they're out, next to a patio. It's something people have to look at. So an old rusty box out there is not the best thing, 5 years in. Okay, so warranty. So on this, I am talking about older units. So I still have a few of these, but I will also talk about the newer units. So currently, or in older units, we have 5-year parts and 2 years labor. What you're going to be up against is 3-year parts and 2 years labor. All of our units come standard with a GFCI rated outlet on the outdoor unit. Now, this doesn't sound like a big deal. I mean, GFCI outlet's only, what, 15 bucks? But it really helps with the noise. What I mean by that is you can help out your neighbor. So the generator's all the way to the right side of your house, and the neighbor on the right side is going to be complaining. Say, hey, when power's out, feel free to plug into my generator, your sump pump, so you don't get flooded. They're not going to care about the noise at that point. Other generators are not going to have an outlet at all, especially the smaller ones. If they do have an outlet, it's likely to not be GFCI rated. And when are you trying to plug stuff into this thing? When it's raining and nasty out. Some manufacturers will even give you a GFCI rated outlet, but it's in a box, so you have to install it on the unit. And maybe it only takes 10 minutes, but it's one more thing you got to do while you're there. So we couple those features with the fact that instead of giving a homeowner 16 circuits, we're giving them the entire house. That's kind of the story across the kitchen table. All those things we just talked about, plus the fact that we're giving you the whole house instead of just 16 circuits. How does that convey? Generally, the unit is going to be in the neighborhood of $250 more. If we take the Pepsi Challenge, a Generac 10kW will come with 12 circuits, not even 16. Our 10kW will come with the whole house. Granted, it has to be a smaller house, something less than a 3-ton unit. The Generac is going to be steel. Ours would be aluminum. They're going to have a 3-year warranty. We're looking at a 5-year warranty. They don't have a remote monitor. Ours comes with the remote monitor. They don't have an outlet at all. We come with a GFCI rated outlet. They will not have the base fascia, and we'll have the base fascia. So cost-wise, it might cost you $250 more for the unit, but the reality is I find that electricians can put these things in cheaper than HVAC guys. So what does that mean? That means this $250 is going to equate to $1,500 across the kitchen table. Maybe $1,000 if you're lucky, maybe $2,000 if you're on the high end. So will those features offset $1,500 or maybe even $2,000? We find that sometimes it does and sometimes it doesn't. So that's the decision you have to make in how it's sold at the customer. Parts, we are a parts distribution center for the Midwest. We've got a ton of stock. I probably won't have the part you're looking for. It's just the way it goes. We do have parts for not only Honeywell, but Generac and other brands of generators made by Generac. All right, so I've talked about the new units. So within the last month or two, we've started receiving some of the newer units, and they've changed or made enhancements to 85, I'll call it parts and pieces. I mean, some of these things were pretty minor, so I'm going to hit the high points. The first thing is, because we have an aluminum cabinet, we are able to be offset 18 inches from the house. You know, that makes it very similar to an air conditioner. But what they've done is put this sticker on the back of the unit that basically says we're able to pass the test for fire protection, meaning that it can be only 18 inches off the wall. There's many other manufacturers out there who are 5 feet off the wall. And there's a lot of, I'll say, houses in Chicago where if you're 5 feet out in the wall, 5 feet from the wall, you're basically in the middle of the yard. It looks really strange. So we're able to be 18 inches off the siding. If there's a window or something that changes it, we're 5 feet then, but then they're 8 feet. They do offer some new transfer switches, but here in Illinois, I do not run into 300 amp pretty much ever. I've run into 800 amps in houses, but never 300. So some strange stuff there. This is just a picture of the new circuit board inside of the transfer switch. And basically, what it's showing you there is you still need some sort of contactor, which we're calling a DLM module, but you need a transformer, and it makes it a little bit easier in terms of wiring because we're dealing with 24 volts, not line voltage. Mobile link. So this is where the old units had the remote monitor. We are offering mobile link. Mobile link is basically a little antenna that comes out of the back of the generator that speaks to the internet via a cell tower. So what this allows the homeowner to do is go onto a website and see exactly what the generator is doing. What is the battery? What are the frequencies? How long has it been out? All those kind of things. And it also allows them to receive emails or text messages if there's a problem. So you're low on battery. It sends them an email and a text message. You can also set up to have the contractor receive the same email, provided the homeowner wants that. So now you know to call the customer and say, hey, we'll be out there tomorrow to look at this. Makes it a lot easier, a lot more proactive. The other thing with this, the homeowner is going to receive 1 year of mobile link free. After that, there's a monthly charge of somewhere between $8 and $9 a month, depending on what type of package they go with. So first year is free. After that, it's $8 or $9 a month to receive the notification. If they choose not to have it, that's okay. The generator still works as intended. They just won't receive emails and have access to the website. The other thing that changed is on the old units, we were 5-year parts, 2 years labor. Now we are 5-year parts, 5 years labor on new units. So full 5 years comprehensive down the line if anything goes wrong with that unit. And I'm running out of time. So if you have any questions, I'm going to stay on the line for just another moment. Or if you email something in, I'll definitely get back to you. Thank you so much for your time. I appreciate it.